Okay, we're going to continue with, this is Pre-Calculus Lesson 3.3, and this is video number 2, and we're starting with example 6, and I don't know which examples we're going through. In the previous examples, we did the expanding using the log properties, and now we're going to condense. I'm going to be honest with you, this is what we do mostly when we are solving equations. So this says example 6, condensing logarithms. So we have separate logs we want to combine into a single log. So condense means combine into a single log. So I'm just going to quick see if I can find the examples we just did. So like this would be an example of a single log, and before we expanded it, but now we're going to go backwards and combine it into a single log. Okay, so I'm just going to start to look for some things that are important. When you have something multiplied out in front, that is going to be that power property that we're going to use. We're actually going to hop that up to be an exponent. And so here is something multiplied out in front. That's going to be the power property. I have two logs added together. Remember, that is the product property. So we're going to combine that into multiplication. So you want to start here. No, we want to start actually with the power property. So we want to take this and hop it up to be an exponent on our x. We want to take this 3 and hop it up to be an exponent on this whole quantity. So my first step is going to look like this. I'm doing the power property first. So log base 10 of x to the 1/2. So this 1/2, I hopped it up and it becomes an exponent. That's why it's called the power property. And then I'm going to say plus this 3 is going to become an exponent right here. Log base 10 of the quantity x plus 1, keep the parentheses because it's that whole quantity to the third power. So that was the power property. Now we have two logs added together. We can combine those into two logs multiplied. So now I have my single log. I think I'm going to do brackets here. So I'm going to say x to the 1/2 times x plus 1 to the third. So that is a single log outside. Typically, x to the 1/2 we write as the square root of x. So I could write this as the square root of x times x plus 1 to the third. So very rarely do you see the 1/2 left there. It should be taken to the next step where you write it as a square root of x. So I've combined this into a single log of all of this. Okay, let's try b. Again, I see a number out in front. I know that's going to hop up to become an exponent. And then here, I just have nothing, so I know I'm going to use power rule first, and then subtraction is going to become a fraction or a quotient. So first step, let's write natural log of x plus 2 squared. So this hops up and becomes an exponent. And then minus natural log of x. And then subtraction is going to become division. So this is going to be natural log of x plus 2 squared over x. So technically, I'm taking the natural log of all of this. So I have combined it into a single natural log. Okay, let's look at this one. Remember, pause the video if you need time to write these problems. So this has an exponent out in front. And then inside, I have two logs added. So this is going to become multiplication. So I'm going to do what's inside these brackets first. So I'm going to keep that 1/3 out of here. And then 2 logs added is going to become a single log with multiplication. This is going to become log base 2 of x times x minus 4. And then here's my 1/3. So I have the single log here, but what I want is to not have this 1/3 out front. So that's going to hop up here. So I'm going to have log 2, I'm going to put my brackets here, x times x minus 4, and my 1/3 will be right there on the outside of that. 1/3 is the same as a third root. I mean, there's lots of different ways you could keep going with this. So I could write this as the third root of x times x minus 4. So I'm going to say, okay, this looks pretty good. Or I could also write this as log base 2 of the third root of x squared minus 4x. I mean, this one might actually be better because it's the factored form. Depending on what you're doing, though, that might be more convenient. Just depends on when we get to solving. All right, so that's example 6, A, B, and C. This is the answers. Okay, this is your turn here. Looks a lot like the one we just did. So I'm seeing quotient rule and power rule. So pause the video, try this one. And then this is your answer. And I'm going to go through this. There's a exponent rule that maybe you might have forgotten. So I'm just going to remind you that when you have an exponent raised to another exponent, you multiply the exponents. So let's see, I would have done my division first. So this would be log 10 of x plus 3. Oops, actually I would have done this first. Divided by x minus 2 squared. So I kind of did 2 steps there. I used the power rule here. At first I didn't notice that. Those are easy to miss. And then I turned subtraction into division. Now I want to get rid of that constant out in front also. So I'm going to have log 10 of, I'm going to do some brackets here, x plus 3 over x minus 2 squared, all of that squared. So this exponent outside should get applied to everything on the inside. You're done here. You combined it into a single log. The rest is just simplifying so it looks like the answer they got. So I had x minus 2 squared, and then I'm squaring it again. So this is 2 and then to the power of 2. So that's log 10 of x plus 3 squared over x minus 2 to the 4th. 2 times 2 is 4. So that's where that 4 came from. Okay. Now we're done with that one. Yeah, we'll put these applications in this video. Hopefully these are quick ones, likely. Oh, actually, we are not doing these. So you're done with the 3.3 video.